today we're going to solve linear systems algebraically. If I don't step on my mic. Looks like we're still waiting for Jose. Everyone else should be finished. No. It is quite humorous, though. And our goal is to solve linear systems algebraically. So what, honey? I did have quite short hair, and I was a tomboy. Okay, so and why to model guitar cells as in problem 55, and you do get to do problem 55 today on your homework. I was going to put in a story problem, I forgot. We'll have to do it as an example of how to do the two story problems that you guys have to do today. I know I forgot to do something. Okay, we ready? Okay. So we're going to talk about solving systems using substitution and elimination. Again, this is review, you guys. So, but it is one of the more difficult concepts in algebra. So we're going to take a little bit more time going over it. So step one is solve one equations for one of the variables. It does not matter. Pick one of the equations and solve it for one of the variables. Pick and solve. Number two says substitute the answer into the other equation. So we're going to solve for one of the variables, and then we're going to take the answer for that equation and substitute it into the other equation. Hence the name substitution. Step three, substitute the answer back into the first equation. So we're substituting twice. And the last step is check your answer. Not everybody does the last step, and that's why you get the answers wrong. Just as a little side note. So solve the system using substitution. So two equations, A and B. I'm going to pick one of those equations and solve for one of the variables. It does not matter which equation I choose. It can either be A or B. Does not matter. Just pick one. Okay? Half of you might pick A and half of you might pick B. It doesn't matter. Okay? You should get the same answer. And of course we should pick the easy one, right? So I'm going to pick A. And it says 3x minus y equals negative 9. Now I could solve for x, but that would leave me with a fraction. Let's solve for y. Add y to both sides. 3x equals y minus 9. Add 9 to both sides. And I get y equals 3x. What did I put for y there? 3x plus 9. Everyone okay with solving for y, right? Slope-intercept form. Okay. That's step one. Pick an equation, solve for one of the variables. Could have I solved for x? Yes. Okay? Whichever one is easier to solve for. Step two says I take this and I substitute into my other equation wherever there is a y, because y equals 3x plus 9. So I'm going to take B. It says 2x plus 4y equals 8. And wherever there's a y, I'm going to put 3x plus 9. I get 2x plus 4 times 3x plus 9 equals 8. Yes, no, maybe so. You okay? Right, all I did was substitute in my y into where y was. Everyone okay? Okay, I guess that's a yes. Okay, then I'm going to solve for x. Now I only have one variable left, right? I only have x left. Solve for x. It's a linear equation now. 2x plus 12x plus 36 equals 8. 14x plus 36 equals 8. Subtract 36. 14x is going to equal negative 28. Divide by 14. And x equals negative 2. Anybody lost yet? Everyone good? You're lost? Where at? 2 plus 12. Right there on the same side of the equal sign? Okay. We good now? Okay. So now the third step says substitute this back into your original equation. Because my answer is x and a y, right? So I need a point. So I've got part of my answer, which is negative 2. I need the other part of my answer. So I'm going to take my answer, substitute it into the other equation, and find out what y equals. Okay? So 3x, which is negative 2, plus 9 equals y. So this is negative 6 plus 9, and so 3 equals y. Did I lose anybody yet? It's just the same as saying 9 minus 6, right? Okay. The last step says check your answer, right? How do we check our answer? Yeah, you take them and plug them into both equations. I'm not going to do that right now. Okay? You have an x, you have a y. You plug them into both equations. Both equations have to be true. We can do it really quick. 3 times negative 2 is negative 6. Minus 3 gives me what? negative 9. Has to be true for both of them. So 2 times negative 2 is negative 4, and 4 times 3 is 12, and negative 4 plus 12 equals 8. Okay? If you get it wrong for either one of the equations, you did the problem wrong. I mean, it's a built-in check to see if you did the problem right. Everyone good with that one? Should we try one? It does, but sometimes we can't graph. That's why they do it this way. Because if you have a problem with like 450, large problems, right? It's not always feasible to graph, right? But good question. Observation. Okay, try this one. I will come around and help you. So try it. Okay, remember you can choose and solve for any of the variables. And if I choose number A, equation A, it's easier to solve for x because x is already by itself. Then I'm going to take this equation and substitute it into equation B for wherever there's an x. And I get 2 times negative 3y plus 11 minus 5y equals 33. Bless you. So then we solve. So we get y equals negative 1. And we're going to take my y and substitute back into here to find out what x equals. So I know x equals negative 3y plus 11. Negative 3 times negative 1 plus 11. 3 plus 11 equals 14. So you were a little bit off, right? Didn't you get 4? Okay. 14 negative 1. Then substitute it back in. So we got 14 plus 3 times negative 1 is negative 3, which, oh my gosh, equals 11. 2 times 14 is 28, minus 5, negative 5 times negative 1 is plus 5, which equals 33. Because 11 divided by negative 11 is negative 1. When you're multiplying, if you owe $6 and you borrow another $5, you owe $11, so that'd be negative 11. Okay? Everyone okay? Yeah, no, maybe so. Okay. That's Richard. Okay, one more. Okay. Attempt this one. This is a lot more work. But luckily, I found out that we don't have to do 3 equations, 3 unknowns, because that problem right there usually takes 3/4 to a page per problem to do. So this is much simpler. We don't have to do it. I was like, I like doing that. And I'm like, well, why don't we have to do that? And they're like, it's not in the course, so we don't have to teach that. You guys don't have to learn it. Be happy. No. We don't have to solve for x, y, and z. Only x and y. Well, isn't it already solved for a variable? Yeah, so you're just going to substitute it. What does y equal? So wherever there's another y in the other equation, what are you going to put? Okay, so here we go. This one's not as difficult as it looks, but everyone gets confused on it because they both are y equals. I don't know why. So this is A and this is B. Step 1 is done. I have A solved for y. What does y equal? 2x plus 2. So wherever there's a y in my other equation, I'm going to put 2x plus 2. So I get 2x plus 2 equals negative 3x plus 4. Who is not okay with that? Great. Okay, so add 3x, 5x plus 2 equals 4. Subtract 2. 5x equals 2. 2/5. Doesn't matter which equation you plug it back into, does it? Both says y equals. Pick one. Plug it into there. Okay? It doesn't matter. So if I choose y equals 2x plus 2, I'm going to get 2 times 2/5 plus 2, which is 4/5 plus 10/5. Who doesn't know what I did there? Everyone knows what I did there? Okay. What is 10/5? I'm just adding 2, right? But to add fractions, you have to have what? Same denominator. So I made a 2 just in a different form, right? Okay with that? Okay. So that equals 14/5. Yeah, 10 plus 4. Not now. It's so bad. 4/5 plus 10/5. I did. I multiplied 2 times 2 and got 4, right? And then it says add 2. So 4/5 plus 10/5 gives me 14/5. Yes, honey? Okay. Y equals negative 3 times 2/5 plus 4, right? So this is negative 6/5 plus 20/5. Oh, which is 14/5. It's not multiplying. Yes, I did, which gives me 4/5. Which one? Not when you're multiplying. Only when you're adding. Are we okay? Does that... Okay, 14/5. And we can plug it back in to check it, but I'm not going to do all the fractions, okay? It's not as easy as the others, but it is correct. All right, any questions on substitution? Okay, it's a lot to take in. So now we're going to move to elimination, which is sometimes easier and sometimes not. I'll just put it that way. Okay? And there's 5 steps for elimination. So step 1 is to arrange the equations with like terms in columns. So all the x's in one column, all the y's in one column, and all the constants in one column. Yes. definitely did it in algebra. Okay. Elimination. Did I spell it wrong? It's entirely possible. Oops, I forgot the I. So sorry. At least it doesn't say Evan only. Okay, gotcha. Which I did do on a sheet I gave to people to do. It said Evan only because spell check didn't tell me it was wrong. So, and spell check didn't tell me that was wrong either. So, get off my back. Step 2, multiply if necessary. Step 3, add the equations together. You okay so far? Step 4, substitute. Yes, we're going to do a little bit of substituting. You get an answer when we add the equations together, and then you're going to take that answer and substitute into one of the other equations, which I'll go over when we actually do a problem. Okay? And the last step, can anyone guess what the last step is? Check your solution. Good. Excellent. I spelled it wrong on 4 slides then. My great spelling skills. Okay. I'm waiting. I'm good. By the way, anything turned in for chapter 3, which was the last thing you turned in, and this one, and what you'll do on Thursday will not go on till next term's grades. Okay? So, will not go on till next term's grades. So for those of you who haven't done them, and look at several of the gentlemen in this classroom. You have a little bit more time to turn in your work. Okay. Everyone good now? Okay, great. All right. Step 5 was check your solution. You said you weren't ready. Okay. So we're going to solve the linear system. We need to make sure we line them up. Look, these ones are already lined up. So I'm going to number them again, A and B. Okay. But my x's are together, my y's are together, and my constants are together in one row. And then we want to see, if we look at them, if I add them together, will I get rid of one of the variables? Yes. So I don't have to do anything special. I'm just going to add them together. What's 4x plus 3x? 7x. Negative 2y plus 2y? 0. Equals 14. Look, I got rid of one of the variables. Okay? Huh? Yeah, now I'm going to divide by 7. And x equals 2. So that was step 3, all 1, 2, and 3 all together. Okay? Step 4 says I substitute. I take my answer and I pick an equation. It does not matter which one you choose. Just pick one. And substitute it back in. Okay? I'm going to choose B, just for the heck of it. 3x plus 2y equals 12. So where there's an x, I'm going to put 2. too bad yet. Yeah, because it does get a little complicated. Remember what number step 2 said? It said multiply if necessary. This one I didn't have to multiply on because I could add them together and get rid of one of my variables. If you add them together and you still have both x and y, you have to multiply by something. Okay, one of the equations, or both. Okay, so then we check. Is it okay if I skip over the checking? Everyone good with that? Okay, great. Okay. Sorry, Jose, I didn't mean to get in your way. We good, Jose? Okay. All right. So normally I would just say you guys do this, right? But because this is a little more complicated. Okay. So step 1 says I need to line up my variables. So I'm going to take equation B. I'm going to get my x's on the same side. And I get negative 3x minus 5y equals negative 21. And then I just like to rename it. I'm going to call it B prime. I know you can't see that. Let me write it in a different color. B prime. Okay, it's still B, just in a different form, right? That's why I called it B prime. And then I'm going to write A underneath it. 2x plus 5y equals negative 11. So if I add those together, will I get rid of one of my variables? Yeah, because I have a negative y, a negative 5, and a positive 5, right? And that makes 0. So negative 3x plus 2x gives me, anybody? Negative 1x, right after x, equals negative 32. Divide by negative 1, and x equals 32. Then pick an equation. Any equation. Let's go ahead and pick B, which is negative 5y equals 3x minus 21. 3 times 32. 96 minus 21. 75. Divided by negative 5. And y equals negative 15. Hey, is it still horrible? Yes, honey. Yes, you could plug it into your B prime also. It doesn't matter. Any of the 3 equations you have. I just did it that way because then I didn't have to move 2 things, right? My y was already isolated, so. But yes, you could. Yes. Because I subtracted it from both sides to get them lined up. Are we okay with that? Okay. Any other questions? Okay. All right. Notice we still didn't multiply by anything. Okay? All we did is line up the terms. Okay. You don't want to go backwards, you want to go forwards. So we want to line up our terms, A and B. And actually, all I have to do is rewrite B with the equal sign on the other side, right? So I mean A. I'm not even naming it A prime because it's still the same equation. I didn't really do anything to it. It's 3x minus 3y equals negative 33. That's A. Okay? Everyone okay with that? Now if I I add that together, do I get rid of any of my variables? No, because if I add it together, I'm going to get 8x minus y. That does me no good. Okay, so I have to multiply by something. Here's where your decision comes in. You can either get rid of the x's or you can get rid of the y's. It doesn't matter. You choose. So there's several different paths you can go down now. Okay? So if I want to get rid of my x's, I have to make these what? 15s, because that's the smallest common denominator. I don't even like using smallest common denominator, greatest, whatever those are. Just multiply them together. One needs to be negative, one needs to be positive, right? So if I was going to get rid of my x's, I'd multiply this by 3 and this by negative 5. Okay? Is everyone okay with that? Because to make these 15s, right, one needs to be positive, one needs to be negative. So I could multiply this by negative 3 and this by positive 5. It doesn't matter, as long as one of them's negative. Okay? But I multiply the opposite by the opposite. If I want to get rid of my y's, which one's already positive, one's already negative, so I only have to multiply by positive numbers, which is always good, right? I need to make these what? 6's. So how do I make a 2 a 6? Times by 3. How do I make a 3 a 6? Times by 2. Now, you will not always have to multiply both equations by something. Sometimes you only have to multiply one equation. Okay? So now I'm going to get a b prime, which is going to be 15x plus 6y equals 3. And I'm going to get an a prime, which will give me 6x minus 6y equals negative 66. This is the normal way. And if you try to do substitution on this, if you look, we're going to have fractions no matter what. If you try and use substitution, okay? So, and graphing is going to be just as ugly because your y-intercept is going to be a fraction, okay? So this is why they come up with other ways to solve the equation. Add them together. 15 plus 6. 21x equals negative 63. Divide by 21. X equals negative 3. Okay, pick an equation. It does not matter which equation you use. We have 5 equations up there. Pick one of them. Okay? So someone said A. So negative 33 equals 3x minus 3y. So negative 33 minus equals 3 times negative 3 minus 3y. Enough 3's in that equation? Minus 33 equals negative 9 minus 3y. Add 9 to both sides. And I get negative 24 equals negative 3y. Divide by negative 3. And y equals 8. Not 6. 8. 8. Negative 3, 8. Why'd I have to change the numbers? Because in order to add these together, if I would have just added these together, what would have I gotten? 8x minus y equals negative 32. That doesn't do me any good if I don't get rid of one of the variables. Right? So I had to multiply by something to change it. So when I added them together, I got rid of one of the variables. Whatever's, yeah, if you wanted to. As long as you get where you add them together, you can get rid of one of the variables. Yes, that's what I did. Okay. Okay, yes. My answer is 8 points. Okay. Okay, this is the answer. It's the point where the lines intersect. I know, everybody's sleepy. Okay, your turn. You can do any method you want. But Dalton was. His mouth was open and was snoring. Yeah. I used all 2 whole bottles of my loose plastic yesterday. No, it didn't work. Come on, work. Yes, honey. Yes, honey. So which one was it? Okay, so how do I, and this is the negative 9, so I need a positive 9. So I multiply this 3 times negative 3. And I type this in on my right. Okay. Oh, let me get the mic. All right, so substitution's not looking good because I'm going to end up getting fractions. So let's use elimination. So I'm going to multiply this equation by negative 3. Because this is a negative 9, and a negative 3 times a negative 3 gives me a positive 9, right? So 2 times negative 3 is negative 6, plus 9y equals negative 12. Whoever multiplied negative 3 times positive 4 and got positive 12, it's wrong. And there were several of you who did that. Just saying. Okay? So this is, 0, right? Equals negative 4. Is that true? Really, it is? 0 equals negative 4? No. No solution. 0 cannot equal negative 4, therefore there is no solution. It's because you walked in. 8 minus 12. Is everyone okay with that now? You add the 2 equations together, right? So 8 minus 12 is negative 4. People are looking confused. Jose, Are we okay? Are you sure? Uh-huh. Okay, next one. Go. Uh-huh. I spent the whole weekend in bed with cramps from hell. It was lovely. Uh-huh. I like Miss Small's idea of camping. You know what Miss Small's idea of camping is? A three-star hotel. Yes, yes. And the sixth graders that they gave her last year tore up her Krabby Hat. Yes. Krabby Hat. She had a little crab, so when she was upset, she'd wear a Krabby Hat, so when everyone came into class, they knew she was not feeling good, so they wouldn't be annoying. So, little sixth graders tore it up. She went through her whole year's supply of tissues the first 2 weeks of school. Because she, no, and the kids were Miss Small and sixth graders. Come on. Good combination? No. Y'all know Miss Small. Come on. Not a good combination. Yes, she retired. Made her teach. They made her teach sixth grade special ed. So she went from history, where you guys had fun and could have fun with her, to sixth grade special ed. So she retired. In a little teeny room with no ventilation. So you know her allergies, right? Yeah, she almost died like 5 times that last year. Yeah. Why not? Okay. So what am I going to do on this one? Times by 6. Okay, times by 6. And I get 6x minus 6y equals 24. 0 equals 0. Is that true? Yes, so what's my answer? No. Infinitely many solutions. Right? We have 3 answers. We can have 1 point, no points, or infinitely many points, right? So when you're solving algebraically, infinitely many points means I have the same thing equaling the same thing. Not a variable, by the way. Okay, all the variables are gone. No solution means 0 equals -4. Can't be true. Yes, honey? Whichever one's easier for you. Some people like elimination, some people like substitution. Whichever's easier for you to do. In the book, it's going to tell you which to do. Okay, so you have a section that says use substitution, one that says use elimination, and one that says you choose. Whichever one you like best or that seems to work the best, do that. If there was like, I would almost, this was pretty easy multiplying by 6. But if there was one in here, I'd probably do elimination on this. I mean substitution. Why? Because I have a variable by itself, right? And you can solve for that and substitute in. So usually if there's a variable by itself, then I'll do substitution. But if there isn't, elimination is usually easier. Does that help? Yes. Yeah. When you add them together, well, then, like the other ones, you add them together. I multiplied by 6 because I wanted to get rid of my x's. And if I multiply 1 by 6, I get 6, and that will make me 0. That's okay. Then you're going to choose what to you're going to multiply. Remember, when we go back here, choose what to multiply them by to make them, when you multiply them, the same. When you add them together, the same. So I chose to make these both 6, right, by multiplying by 2 and 3. So you have to do that. Does that make sense now? That would be a totally different, right. You would get something else. You'd get a point where they would intersect. Okay? All right, everyone okay? It's okay. Then it'll be equal 0, right? So you're saying if I have 3x equals 2y, okay. Then when you add them together, you're going to get 2x minus 2y. You multiply something by, so if I have x minus y equals 5, right? And x minus y equals 0. You have to multiply one of these by negative 1. So then I get negative x plus y equals negative 5. Negative 5, 0. Yeah, because this is 0, right? And this is 0. So that equals 0. Does that answer your question? Okay. Okay. Yes, honey. Infinitely many solutions. Okay. So we solve linear systems algebraically. Here, ladies and gentlemen, help from online. Okay? So, if you feel you're going to need help online, the top one is substitution, the bottom one is elimination. Okay? So, you can grab out your camera, take a picture, write it down, whatever you want to do. See that homework right here, over here? No, over here. Yeah. Okay. And then if all of a sudden you really feel like you want to do some codes here, you want to test yourself because you just feel like doing, math because it's cool. I know math is cool. You can go on and quiz yourself. It gives you 5 questions and tells you how many you get right or wrong. No, there's no way for me to go on and tell if you did it or not. If you can print it out, fine. Sure. Yes. Right now, that's it. Next quarter will be tissues. I'll save them for next quarter. What, honey? ATA. You can't bring that many. Doesn't help. You can only bring 20 tennis balls. Yeah, it will. That's the code. You put in the code ATA0702. No, I think it's 2 separate boxes on there, so you do the letters in one box and the numbers in the other box. Okay? Yes, honey. Yes, honey. Okay, everyone good? And this is your homework. Hold on, let everyone write their homework down. It's like 20 problems. Oh, and I didn't do the story problem, so hopefully you can figure them out. So sorry. I was going to, but I forgot. There's 2 story problems. But there is an example in the book on how to do them. So if you turn back in your book a few pages, it shows you how to do stuff. Oh my gosh, imagine that.